Welcome aboard the interstellar starship Genesis. Together, we'll journey beyond the boundaries of known space, explore distant worlds, and witness the quiet wonders of the universe. If you enjoy relaxing sci-fi sleep stories like this, please consider liking this video and subscribing to join us on future voyages. Now find a comfortable place to rest. Take a slow, gentle breath, and whenever you're ready, let the journey begin. First contact. Chapter 1. The signal returns. Yesterday, the universe presented Genesis with a question, not an answer, not a message, simply a question. For less than a second, the communications array detected a radio signal unlike anything the onboard software expected to find. It was narrow, exceptionally narrow. Then, it was gone, by itself. The observation meant almost nothing. Every day, scientific instruments record events that later proved to be ordinary. A brief fluctuation in electronics, thermal noise inside a receiver, a cosmic ray striking a sensitive detector, an unexpected reflection from a distant spacecraft. Even the most sophisticated observatories occasionally mistake the unusual for the extraordinary. That is why scientists have learned a simple rule. The more remarkable a discovery appears, the harder they try to prove it wrong. As you make your way through the quiet corridors of Genesis, the rest of the ship feels completely unchanged. Breakfast is being served in the galley. The hydroponics gardens are beginning another artificial sunrise. Engineers are reviewing overnight diagnostics. Life support systems continue recycling every breath the crew exhales. Water completes another endless journey through pumps, filters, and reservoirs before returning to someone's morning cup of coffee. Life aboard an interstellar ship does not pause for unanswered questions. It continues, one ordinary day at a time. Your assignment this morning brings you back to the communications laboratory. The room is quiet. Soft blue displays illuminate rows of receivers and signal processors that have been listening to the universe every second since Genesis departed the solar system. No one here is searching for aliens. They are searching for understanding. Those are not always the same thing. Today's objective is surprisingly simple. Repeat yesterday's observation in science. Repeatability is the beginning of confidence. If an observation cannot be repeated, it cannot be trusted. The ship slowly adjusts its orientation, not by much, only a fraction of a degree. Tiny attitude-controlled thrusters fire for barely a moment, placing Genesis back on precisely the same line of sight through the galaxy. Out there's no horizon, no edge where space disappears from view. The receivers are not looking ahead of the ship. They're looking across hundreds, perhaps thousands, of light years toward exactly the same coordinates where yesterday's anomaly appeared. Before the observation begins, the communication systems perform another complete calibration. Internal reference sources verify the receivers. Frequency standards are checked. Timing systems synchronize with the ship's atomic clocks. Background noise is measured. Every instrument reports the same result. Nominal. Only then does the observation begin. For several long minutes, very little happens. The displays quietly fill with familiar data. Natural radio emissions from distant stars. The rhythmic pulses of cataloged pulsars. The faint background whisper left behind by the early universe itself. Every signal behaving exactly as physics predicts. It is almost disappointingly ordinary. You begin to understand why astronomy demands patience. Hours of careful observation often produce nothing more exciting than confirmation that yesterday's understanding was correct. And that, too, is discovery. Then, a soft notification sounds, not an alarm, simply a request for attention. One receiver has recorded an emission exceeding the system's confidence threshold. The room remains silent. No one rushes toward the displays. The observation is allowed to complete without interruption. Only after the recording ends does everyone quietly gather around the analysis console. There it is. Again, the same frequency, the same astonishingly narrow bandwidth, the same position in the sky for just under 1 second. Then, nothing. The room remains completely still. No one speaks the words that everyone is carefully avoiding, because every scientist aboard Genesis understands. One repeated observation is enough to begin an investigation. It is not enough. To reach a conclusion, tomorrow's greatest discovery must first survive today's questions. Chapter 2: Eliminating Ourselves. There's an old saying among engineers: when something unexpected happens, assume it is your own equipment until you can prove otherwise. It is not pessimism, it is discipline. The signal has now appeared twice. The same coordinates, the same frequency, the same remarkably narrow bandwidth. That is enough to justify an investigation. It is not enough to suggest an explanation. As another quiet morning settles across Genesis, you remain inside the communications laboratory. The room has changed very little. The same displays, the same quiet conversations, the same steady hum of receivers listening to a universe that has remained silent for billions of years. Only now, every familiar sound seems just a little more important. The lead systems engineer outlines the day's objective. Before anyone studies the stars, they must eliminate the ship itself. Modern spacecraft are surprisingly noisy, not acoustically, electromagnetically. Every electrical system aboard Genesis produces tiny emissions: power converters, navigation computers, environmental controls, water pumps, lighting systems. Even the processors used to analyze radio signals generate their own electromagnetic fingerprints. Normally, these are carefully cataloged and filtered by the ship's software. But assumptions have no place in an investigation like this. Today, everything will be tested again, one system at a time. The first receivers are disconnected from the primary processing network and switched to an independent backup chain. If the signal disappears, the original electronics become the obvious suspect. The observation begins. Minutes pass. The familiar background returns. Natural radio sources, known pulsars, the faint hiss of the universe itself. Nothing unusual. Then, the narrow signal appears once more, exactly as before. The backup receivers recorded it too. One possibility. Quietly disappears. Next, the ship's internal communications transmitters are powered down for a scheduled maintenance window. Only emergency systems remain active. Another observation begins. Again, the signal returns, exactly where it should, exactly when expected. Another possibility removed. Throughout the day, the investigation continues. Power distribution systems are monitored for harmonic interference. Navigation radar is temporarily isolated. Environmental systems are examined for unexpected emissions. Maintenance drones suspend routine operations. Every subsystem that could conceivably generate radio noise is questioned. measured, compared, ruled out, you begin to appreciate something unexpected. Most scientific discoveries are not made by finding new answers. They are made by patiently removing old ones. Each explanation that fails allows the truth to occupy a little more space. Late in the afternoon, the communications laboratory grows unusually quiet, not because anyone believes they have found evidence of another civilization, but because one conclusion is becoming increasingly difficult to avoid. Nothing aboard Genesis appears capable of producing the signal. The possibility is written carefully into the investigation log. Local interference not supported by current evidence. Not impossible, simply unlikely. The distinction matters. Science rarely deals in certainty. Instead, it measures confidence. Outside the laboratory, life aboard Genesis continues almost unchanged. Children still attend their lessons. Meals are shared. Plants continue growing beneath artificial sunlight. Exercise schedules are followed. The ship keeps moving silently between the stars. Because whatever the signal may prove to be, human life still depends on ordinary routines. As your shift comes to an end, you pause for one last look at the investigation log. Several explanations have already disappeared. Many more remain. If the signal did not come from Genesis, then tomorrow, the universe itself becomes the next suspect. Chapter 3. The universe as the suspect. By the following morning, the investigation has already become noticeably quieter. Not because interest has faded, quite the opposite. The more carefully the evidence is examined, the fewer words seem necessary. Yesterday, the crew spent an entire day searching for faults aboard Genesis, power systems, communications equipment, navigation electronics, receiver arrays, one by one. Each possibility became less likely, not impossible, simply unsupported by the evidence. That left only one place to continue looking: outward. As you enter the communications laboratory, a different display occupies the center of the room. The signal itself has almost disappeared from view. Instead, the screen is filled with star catalogs, radio source databases, spectral libraries, astronomical surveys collected over generations. The investigation is no longer asking, "What did we detect?" It is asking, "What has already been discovered here?" Modern astronomy rarely begins with a blank page. Long before Genesis left Earth, powerful observatories had spent decades mapping the radio sky. Every pulsar, every known quasar, supernova remnants, molecular clouds, star-forming regions, galaxies emitting powerful jets from the enormous black holes at their centers. Each had been carefully cataloged, measured, named. The universe had already introduced itself, at least in part. Your task this morning is surprisingly simple. Compare. Nothing more. The coordinates of yesterday's observation are entered into the astronomical archive. Almost instantly, nearby objects begin appearing across the display. A pulsar, several distant galaxies, a faint molecular cloud, all expected, all well understood, one by one. Their known radio signatures are compared with the recorded observation. The pulsar is quickly dismissed. Its radio pulses repeat with astonishing precision, but across a broad range of frequencies. The signal recorded yesterday occupied only an extraordinarily narrow slice of the spectrum. The two cannot be confused. Next, the molecular cloud. Certain molecules drifting through interstellar space naturally emit radio waves as they change energy states. Hydrogen, hydroxyl, water vapor. Astronomers have used these emissions for generations to map the structure of our galaxy, but every element speaks at its own characteristic frequencies. Nature follows rules. The recorded signal does not match any known molecular transition. Another explanation quietly fades away. The investigation continues throughout the morning. Known quasars, radio galaxies, magnetars, even the possibility of an unusually energetic flare from an otherwise ordinary star. Each comparison ends the same way. Close, but not close enough. You begin noticing something unexpected. Nobody seems disappointed when another explanation survives. Instead, the crew appears relieved whenever the evidence points toward an ordinary answer. That is how science protects itself. A remarkable conclusion is never the goal. An accurate one is. Hours pass. Outside the observation windows, nothing changes. The stars remain perfectly still. Light that began its journey hundreds, perhaps thousands, of years ago continues arriving at Genesis exactly as it always has. The universe feels ancient, patient, completely indifferent to the questions being asked inside this small ship. Late in the afternoon, the latest comparison completes. The analysis software quietly updates its summary. No cataloged natural radio source currently explains the observation. The wording is careful, deliberately careful. It does not say unknown. It does not say artificial. It simply acknowledges a limitation. Among everything humanity has observed so far, nothing appears to fit. You read the sentence twice, then close the report, because another lesson has begun to reveal itself. Not finding an explanation is not the same as proving one does not exist. The universe has surprised humanity many times before. Perhaps this will become one more example. Or perhaps tomorrow's investigation will begin asking a different kind of question. Not where the signal came from, but how it behaves. Chapter 4, Following the Physics. By the fourth day, the question itself had begun to change. No longer, what is the signal? But what does the signal tell us about its source? Every explanation that could be tested against Genesis had been tested. Every known natural radio source within the astronomical archives had been compared. Nothing had yet provided an answer, so the investigation turned to something that could not be argued with: physics. As you arrive at the communications laboratory, the signal itself is no longer the center of attention. Instead, several displays are filled with graphs, frequency measurements, timestamps, orbital calculations, tiny changes that would be meaningless to almost anyone, yet might reveal everything to those who knew how to read them. One of the astrophysicists quietly explains today's objective. Nothing in the universe is truly motionless. Stars orbit the center of the galaxy. Planets orbit their stars. Galaxies drift through expanding space. Genesis itself continues its silent journey beyond the solar system. When two objects move relative to one another, light changes, not its speed, its frequency. The effect is known as Doppler shift. It is the same phenomenon you have heard countless times on Earth. As an ambulance approaches, its siren sounds slightly higher. As it drives away, the sound becomes lower. Radio waves behave in exactly the same way. If the source of yesterday's signal is moving relative to Genesis, its frequency should drift, perhaps only by a few fractions of a hertz, but enough for modern instruments to measure. You watch as the receivers compare observations collected over the past several days. One recording overlays another, then another. The differences are almost impossible to see until the computer removes Genesis from the equation. Every tiny maneuver made by the ship, every attitude adjustment, every correction from the reaction control thrusters, every kilometer traveled since the first observation is mathematically removed from the data. The Earth's former orbit around the Sun, already accounted for before Genesis departed. The ship's own motion, now removed as well. What remains should belong only to the source itself. The room grows quieter, not with excitement, with concentration, because this calculation cannot be rushed. A single incorrect assumption could create a drift that does not truly exist, or erase one that does. Several independent software systems perform the same calculations, then compare their answers. One by one, they agree. The signal is drifting, only slightly, only enough that most instruments built a century ago would never have noticed. But it is there, measured, verified, repeatable. You ask yourself what that really means. The answer is surprisingly modest. Not that the source is intelligent, not even that it is unusual. Only this: whatever produced the signal, it is not standing still. Somewhere across the galaxy, something is moving, perhaps orbiting a distant star, perhaps rotating, perhaps carried by forces humanity has not yet understood. The investigation log grows by a single line. Frequency drift consistent with an astronomical origin. The wording is deliberate. No conclusions beyond the evidence, no speculation, only what the measurements support. Outside, the stars remain unchanged. The same light continues crossing unimaginable distances before arriving at Genesis. The universe offers no explanations, only observations. As your shift comes to an end, you find yourself looking less at the signal and more at the numbers surrounding it, because you are beginning to understand something every scientist eventually learns. The greatest discoveries rarely arrive with certainty. They arrive, one carefully verified measurement at a time. Tomorrow, the investigation will ask a question that physics alone cannot answer. If the signal truly comes from somewhere among the stars, does its structure resemble nature or intention? Chapter 5. Nature or intention? There is a moment in every scientific investigation when the question itself becomes uncomfortable, not because the evidence has become frightening, but because the remaining possibilities are no longer familiar. For 4 days, you have watched the signal survive every ordinary explanation. It was not produced by Genesis. It did not resemble any cataloged radio source. Its frequency drifted exactly as a distant astronomical object should. Each discovery narrowed the field, yet none of them answered the question that quietly occupied everyone's thoughts. Could nature still explain this? This morning, the communications laboratory feels different, not tense, focused. The conversations are shorter, the observations more deliberate. No one is trying to prove the signal is artificial. They are trying, one final time, to prove that it is not. A large display fills the front of the laboratory. It contains no dramatic images, only mathematics. Frequency, bandwidth, polarization, signal-to-noise ratio, persistence, measurements that to most people would appear almost meaningless, yet together they tell the story of the signal itself. One of today's first observations concerns its bandwidth. Nearly every natural radio source spreads its energy across a range of frequencies, even remarkably precise astronomical objects. like pulsars, produce emissions that occupy measurable portions of the radio spectrum. This signal does something different. Its energy remains confined within an extraordinarily narrow band, so narrow that no known natural process has ever been observed to produce it continuously. The room grows quiet, not because the result is unexpected, but because every unusual measurement demands another attempt to explain it. The software repeats the analysis, then a second system repeats it independently. The numbers remain unchanged. Another possibility begins to fade. Attention shifts to polarization. Radio waves possess an orientation, much like sunlight reflected from the surface of a lake. Natural sources often produce polarization, but it usually changes as the waves pass through magnetic fields, interstellar gas, and dust during their journey across the galaxy. The signal's polarization remains astonishingly stable. Again, the observation proves nothing by itself, yet it quietly joins every measurement already collected, one thread woven into a much larger picture. As the day continues, the computers search for repetition, not language, not symbols, simply structure. Nature often repeats itself. Pulsars spin with extraordinary regularity. Planetary orbits repeat. Atomic transitions occur at precisely defined frequencies. Order alone is not evidence of intelligence. The investigation, therefore, asks a more careful question. Does the signal behave like any known natural process? Hour after hour, the answer remains the same. No convincing match is found. You begin to appreciate just how difficult science makes extraordinary discoveries at every stage. The investigation has offered nature another opportunity to explain itself again and again. No one aboard Genesis wants the universe to become a stranger. They simply refuse to ignore what the measurements continue to reveal. Late in the afternoon, the lead astronomer quietly summarizes the day's work, not with certainty, but with precision. The signal possesses characteristics that are presently inconsistent with known natural radio phenomena. The statement is immediately entered into the investigation log, carefully worded, carefully limited. It does not claim intelligence. It does not claim communication. It claims only what the evidence supports, that something observed has not yet found a home within humanity's current understanding of nature. Outside, the stars remain as silent as they were yesterday, as silent as they have been for billions of years. The universe offers no reassurance, no confirmation, only light, arriving patiently across impossible distances. As you leave the laboratory, one thought remains with you. Perhaps the greatest strength of science is not its ability to discover new things. Perhaps it is its willingness to admit when it has finally run out of ordinary explanations. Tomorrow, the investigation will take its most important step yet. For the first time, Genesis will ask another observatory to look. Chapter 6. Independent confirmation. There is a quiet rule that guides every scientific discovery. Never trust a single instrument. No matter how carefully it has been built, no matter how precisely it has been calibrated, every instrument can fail. The only reliable way to separate discovery from deception is agreement, independent agreement, as you enter the communications laboratory. Today's investigation has already begun. The signal itself is no longer the focus. Confidence is. For nearly a week, the crew has questioned every ordinary explanation. Genesis has questioned itself. Astronomy has questioned the universe. Physics has questioned the measurements. Now, the investigation must answer one final question. Would another instrument reach the same conclusion? Genesis was designed for exactly this purpose. Its scientific payload does not rely on a single receiving array. Multiple high-gain antennas are mounted along different sections of the ship. Each was built with independent electronics, independent signal processors, independent calibration systems. If one instrument develops an unnoticed fault, the others should disagree. That disagreement is often more valuable than agreement. This morning, the primary communications array remains silent. Instead, a secondary astronomical receiver begins observing the same coordinates. The software used throughout the previous week is not loaded. A completely different processing system analyzes the incoming data. Different algorithms, different filtering methods, different assumptions. If the signal survives, it will have passed one of the most demanding tests science can offer. The observation begins. Minutes pass quietly. Background radio emissions fill the displays. Known pulsars appear exactly where they should. Hydrogen emissions from distant regions of the galaxy paint faint lines across the spectrum. Everything behaves as expected. Then, a narrow signal appears. The room remains silent. No one approaches the display. No one interrupts the observation. Experience has already taught the crew the importance of patience. The recording completes. Only then does the analysis begin. The new receiver measured the same frequency, the same bandwidth, the same Doppler drift, the same position among the stars. The results are compared with every previous observation. Independent measurements, arriving at the same answer, one after another. The investigation continues. Archived survey data collected before Genesis departed Earth is retrieved from the ship's scientific library. Decades of observations from radio observatories across the solar system are searched automatically. The same coordinates, the same frequency, the same region of the sky, hour after hour. The archive quietly reveals its history. Nothing. The signal does not appear. Not because it was overlooked, simply because it was never there. Or, perhaps, it had never been observed at the necessary sensitivity. The distinction cannot yet be made. Late in the afternoon, the scientific review board aboard Genesis gathers for the first time since the investigation began. Not to celebrate, not to speculate, only to decide whether the evidence justifies continuing. The conclusion occupies a single sentence. The observation has been independently reproduced using multiple instruments and independent analysis systems. Nothing more, nothing less. You read the statement slowly. It feels strangely ordinary, and yet it changes everything. Not because it identifies the source. It does not. Not because it proves intelligence. It cannot. It changes everything because the investigation has crossed an invisible threshold. The signal is no longer a curious measurement recorded by one instrument. It has become an astronomical observation, a phenomenon that exists independently of the machine that first discovered it. As you leave the laboratory, you pause beside the observation window. The stars look exactly as they did yesterday, silent, patient, unchanged. Only your understanding has changed. Tomorrow, for the first time, the investigation will allow itself to ask a question that has remained carefully unspoken. Not whether the signal exists, not where it came from, but whether nature can still explain it. Chapter 7. The Burden of Proof. One of the greatest misconceptions about science is that discoveries happen the moment something new is observed. In reality, the observation is often the easiest part. The difficult work begins afterward. For nearly a week, you have watched the investigation grow one careful step at a time. The signal returned. Genesis eliminated itself as the source. Known astronomical phenomena failed to explain it. Independent instruments confirmed the observation. Every conclusion had been deliberately small, measured, careful, each one earned. Yet one question still remained untouched, not because no one had thought about it, but because everyone understood its weight. What evidence would be required before humanity could honestly say, "This was made intentionally"? As you enter the communications laboratory, the atmosphere feels quieter than it has all week. The urgency has disappeared. Only concentration remains. The large display at the front of the room contains no images of distant stars, no dramatic visualizations, only a single sentence. Criteria for artificial origin beneath it. A list slowly grows, not conclusions, requirements. The first is familiarity. If a natural process already explains the observation, the investigation ends. The signal may still be fascinating, but it is no longer mysterious. The second is repeatability. A single appearance proves nothing. A phenomenon that returns under the same conditions can be studied. The third is independent confirmation. No discovery belongs to one instrument or one observer. It belongs only to evidence that survives every attempt to disprove it. The fourth criterion is perhaps the most difficult. Does the signal contain information that nature has never been observed to produce? You spend much of the morning studying examples from history. Pulsars once confused astronomers because of their astonishing regularity when they were first discovered. Some researchers jokingly labeled them LGM, little green men. The joke did not last long. Within months, additional pulsars were found. The physics became understood. A remarkable mystery quietly became another chapter in astronomy. The lesson remained: never mistake surprise for proof. Throughout the afternoon, the investigation searches for something far more subtle than words. Mathematics, prime numbers, simple ratios, repeating intervals, any structure that would be extraordinarily unlikely to emerge from known physical processes. The computers examine millions of possible relationships. Again and again. Nothing. The signal remains extraordinarily narrow, extraordinarily stable, yet internally, it appears almost featureless. No modulation, no encoded information, no recognizable sequence. You find the result strangely comforting. Had the signal immediately contained a message, the investigation would have become something entirely different. Instead, science is allowed to proceed at its natural pace, patiently, methodically. Late in the day, one final report appears. The room grows silent as everyone reads the same conclusion. No evidence of information bearing modulation detected. Several people quietly nod, not with disappointment, with understanding. The report continues. The physical characteristics of the source remain inconsistent with known natural radio phenomena. The distinction is profound. Genesis has not discovered a message. Genesis has not discovered another civilization. Genesis has discovered a phenomenon that refuses to fit within humanity's current understanding of the universe. As you leave the laboratory, you pause beside the observation window. Somewhere beyond those countless stars, the source continues exactly as it has before. completely indifferent to the questions it has inspired. You realize something then. Perhaps the universe never intended to answer humanity all at once. Perhaps it answers one carefully measured observation at a time. Tomorrow, the investigation will begin again, not because the crew expects certainty, but because every discovery deserves one more question. Chapter 8. First Contact. There comes a moment in every great scientific discovery when the evidence becomes too significant to ignore and too incomplete to fully understand. For 7 days, the crew of Genesis has asked the universe the same question, again and again. Not because they expected a different answer, but because science has learned that truth survives repetition. The signal returned. Genesis was eliminated as its source. Known astronomical objects were ruled out. Its motion through space followed the laws of physics. Independent receivers confirmed every observation. Every measurement had been questioned, repeated, verified. Nothing about the investigation had been rushed. Nothing had been accepted simply because it was extraordinary. And yet, the extraordinary remained. As you enter the communications laboratory, the room feels quieter than it has all week, not with anticipation, with reflection. The investigation has reached its final review. Representatives from every scientific discipline aboard Genesis have gathered around a single display. Astronomers, engineers, physicists, communications specialists. Each has spent the past week trying to prove the same thing, that the universe was behaving normally. One final report appears on the screen. No dramatic graphics, no headlines, only the evidence. The signal has been observed repeatedly. It has been independently confirmed. It does not originate from Genesis. Its Doppler drift is consistent with an astronomical source. Its bandwidth is narrower than any known, naturally occurring continuous radio emission. Its frequency remains extraordinarily stable. No catalogued astronomical object explains its characteristics. The room remains silent. No one reaches for applause, because every person present understands something that the rest of humanity does not. Discovery often arrives quietly. Someone finally speaks. If it isn't natural, the sentence trails away. No one finishes it. Not yet. The senior astronomer studies the report for several long moments, then quietly closes it. There may still be a natural explanation. His voice is calm, steady. There may be physical processes we have not yet discovered. Several people nod. No one disagrees. The history of science is filled with mysteries that eventually found ordinary explanations. No one aboard Genesis wishes to repeat the mistakes of the past. Another long silence follows. Then he continues. But based on everything we know today, an intelligent origin can no longer be dismissed. The words settle gently across the room. No one celebrates, no one cheers, because everyone understands the weight of what has just been said. Not that humanity has found proof, not that another civilization has been discovered, but that, for the first time in history, the evidence has carried humanity to a place it has never stood before. You find yourself walking toward the observation window, beyond the glass. The Milky Way stretches across the darkness exactly as it did yesterday, exactly as it did 1,000 years ago. Nothing in the universe appears different, and yet everything feels different. For as long as people have looked into the night sky, we have wondered whether life found another way to awaken. whether somewhere beyond our own small world, another civilization learned to ask questions, to build, to explore, to look back into the darkness with the same curiosity. Perhaps this signal is not the answer. Perhaps tomorrow, someone will discover the ordinary explanation that has escaped everyone so far. Science demands that possibility remain open. But if the evidence continues to survive every question, every measurement, every attempt to prove it wrong, then you may be witnessing the beginning of the greatest discovery humanity has ever made. Not because you have heard another civilization speak, not because anyone has exchanged a message, but because for the first time, humanity can no longer honestly assume that it is alone. You remain beside the window for a long time. The stars offer no explanation, only their ancient light. Some of it began its journey toward Genesis, long before the first pyramids were built, some before the dinosaurs disappeared, some before human beings existed at all. Tonight, one tiny point among those countless stars carries a question that has crossed unimaginable distances, and somewhere, perhaps hundreds, perhaps thousands of light years away, something may have begun a journey toward us long before humanity ever dreamed of reaching the stars. You take one final look into the darkness. The universe is still silent, but silence no longer means the same thing. Our journey comes to an end, for now. Thank you for traveling aboard the interstellar starship Genesis. If you'd like to continue exploring the stars with us, please consider subscribing for future voyages. Until we meet again, sleep well and safe travels.